Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at grade 11 and 12 Maths Analytical Geometry Complete Exam Question, Everything You Need to Know. And this is from the November 2018 examination, paper 2. Now this is going to be a little bit of a long video because with analytical geometry, we have to answer all our questions in a sequential manner. So our thinking cannot be fragmented, and we have to look at everything in order. So just bear with me and try to answer the question before you can look at the solutions. Now let's read the question. It says, in the diagram, K is -1 and 2, L and N 1 and -1 are vertices of a triangle KLN, such that LKN is 78.69 degrees. KL intersects the x-axis at P. KL is produced. The inclination of KN is theta, and the coordinates of M are -3 and -5. So all this information is on our diagram. As you can see, we've got an angle 78.69 degrees, LKN, and this is theta, the angle of inclination. Now, the first question is, calculate the gradient of Kn. Now, before we start, remember that you have to know all your formulas. Formula sheet will be given to you in the exams, but it's important for you to know your formulas because each one of these will be tested. Gradient, size or the angle of inclination, the, once again, gradient formula in two different ways, and I'll talk about all that in today's video. Determine the equation of the straight line, so we need to know that formula, the distance formula for length, and so on and so forth. So let's look at this first question, the gradient of Kn. So basically the gradient of Kn is, they want us to find the gradient of this particular line right here. So we're going to do that, and remember the gradient formula now is basically y2 minus y1 all over x2 minus x1. So that's my gradient formula. So basically I'm just going to say 2 minus -1 all over -1 minus 1. So let's go write that answer down. So gradient of Kn 3.1.1. So 3.1.1 gradient of Kn. Let's write the formula again, y2 minus y1 all over x2 minus x1. And what will that give us? 2 minus -1 will be 2 plus 1. 2 plus 1. And here we got -1 and -1, which is -2. So let's write -1 minus 1. So we got 2 plus 1 is 3 over -2. So it's -3 over 2. Therefore, the gradient of Kn is -3 over 2. The next question, the size of theta, the angle of inclination. Now, they want us to find this angle. Now remember, the angle of inclination is the angle that the line makes with the positive x-axis. So there's the positive x-axis over here. And you can see this is an obtuse angle. Therefore, you can look at this gradient, which is a negative gradient. Now, this is how we deal with a negative gradient or an obtuse angle, which is an angle of inclination. So remember now, what is the formula for gradient? The formula for gradient is also m equals to tan of theta. Therefore, theta equals to tan inverse of m. Alright, so that's if your angle of inclination is given. You can find the gradient of this line. So also, if you are given the gradient, you can find the angle of inclination. Alright, so let's go and write that down. Therefore, for 3.1.2, our solution would look as follows. We'll say theta equals to tan inverse of m, and remember the gradient we just found it in the previous question, which is -3 over 2. So we'll say tan inverse of -3 over 2, but because this is a negative gradient, we must add 180 degrees because we're going to get an obtuse angle. Let's go work that out. So we'll say shift tan, and that's -3 over 2 plus 180. So that's 123.69 degrees. 123.69 degrees. Okay, so that is my angle of inclination, theta. If you have a positive gradient, you're going to get an acute angle. If you have a negative gradient, you're going to get an obtuse angle. Hence, we'll put in the negative gradient and we'll just add 180 degrees. Okay? Now, let's go look at 3.2. Show that the gradient KL is equal to 1. So the gradient KL is the gradient of this line here. So there's KL there. Now let's look at that very carefully. So if you look at that gradient there, now remember that we need 2 points on the line, or we need the angle of inclination there to find the gradient of the line. But what do we already know about? So we just found theta, and theta is 123.69 degrees. So 123.69 degrees. So if you look at that, if you look at this particular triangle here, you'll be able to see that KPO is a triangle. And if you look here, 123.69 of theta is an exterior angle of the triangle. And what do we know about an exterior angle of a triangle? Exterior angle is equal to the sum of the interior opposite angles. So therefore, KPO, and just write it here, KPO will equals to theta, which is 123.69 degrees, minus this angle here, which is 78.69 degrees. And if we put that in our calculator, we should get 123.69 minus 78.69 equals 45 degrees. We got 45 degrees. So our angle here is 45 degrees. So we can use that formula. M equals to tan of theta, which is tan of 45 degrees, and tan of 45 is 1. But let's just put it there in the calculator just to show you. Tan of 45 is 1. So therefore the gradient is equal to 1. Okay, so let's go write our solution immediately. So 3.2 okay, and that should suffice. Now, next question is 3.3. Determine the equation of the straight line KL in the form y equals to mx plus c. Now, this is what I mean by sequentially answering questions in analytical geometry. So, normally I like to show you specific things in my video lessons. But with analytical geometry and geometry, you have to answer the whole question from the beginning, because it's like climbing up a ladder. You have to answer the question sequentially. An example of that would be, I cannot answer question 3.3 without the solution from 3.2 and so on. So determine the equation of the straight line KL in form y equals to mx plus c. So therefore, we now know that the gradient is equal to 1. So the gradient of this line KL is equal to 1. Because it was a show that question, you can still answer this question 3.2, because they told you show that the gradient is equal to 1. So what are we looking for? We're looking for a point on the line to find the equation of this line. And there's the point here. K is equal to minus 1 and 2. So now we can just substitute that particular point to find our y-intercept. And if you extend the line, you'll see that your y-intercept is going to be some positive value. Alright, so let's go write that down. So for 3.3, solution would look as follows. 3.3, our point is k minus 1 and 2. So we'll write down k minus 1 and 2, and our gradient m is equal to 1. So we'll write down the formula y minus y1 equals to m into x minus x1. So let's substitute. So now we're going to say y minus 2 equals to m, which is 1 into x. Minus minus 1 is plus 1. Therefore, y will equals to, we open the brackets there, you'll get x plus 1. And then minus 2, take it to the right hand side, becomes plus 2. So therefore, y equals to x plus 3x plus 3. So that's the equation of our line KL. And next question is determine the length of KN. Determine the length of KN, 3.4. So for 3.4, the length of KN, we're going to use the distance formula for length. And the distance formula is as follows: x2 minus x1 all squared plus y2 minus y1 all squared equals 2. So Kn, let's go look at that. There's K and there's N. So there's my x, let's call it x2, y2, and let's call it x1, y1. So we got minus 1 all squared. Let's substitute. Say minus 1 all squared plus y2 minus y1 will be 2 minus 1. 2 minus 1. 2 minus 1 is 2 plus 1. Remember, minus times a minus is a plus. Let's put that in our calculator. Square root minus 1 squared plus, and in here in brackets, 2 plus 1 squared equals to square root of 13. Kn equals to square root of 13. Okay, so for 3.4, the length of Kn is equal to root 13. Learners, I'm going to stop there for this particular video, and I'm going to make a part 2 to answer the rest of the questions. If you haven't subscribed already, make sure to subscribe to JL Maths. Also like my Facebook page, Justin Lazarus Mathematics. You can watch all videos in order of the work schedule on jlmaths.com. And I'll catch you in the next video.